Hello everyone. First of all, I would like to thank Ekoparty for giving me the opportunity to come and present at the conference. Virtually though, Ekoparty has been one of the conferences that I really want to attend. Hopefully next year, maybe. So today we are going to talk about assessing IoT with EXPLIoT framework. A bit of background about me. I run a company called Pi2, and we're known for a few things. We organize a security conference in India called NullCon, and we also organize a hardware security conference in the Netherlands and US called hardware.io. Besides that, we specialize in IoT embedded web and cloud security assessments. I've also developed a few open source software. EXPLIoT is one which I'm going to be talking about. Uh, I also wrote a software called Diva Android, which was basically a vulnerable app. Diva is short for damn insecure and vulnerable app. I thought it would sound better than DVIA. Other than that, I give talks and trainings and workshops at various conferences like DEF CON, Hack in Paris, BruCon, Black Hat, and so on and so forth. So let's quickly get down into what the talk is about. So basically, I'm going to talk about the challenge with respect to IoT, the challenge that we faced, obviously. And I'm sure if you are into IoT pen testing, you would kind of relate with the problems that we are going to discuss. And then we're going to focus on we learned it the hard way by starting IoT and embedded pen testing and research, and then we went back to the drawing board and thought of ideas and ways to make it easy for ourselves as well as the security community, and the result was EXPLIoT framework. So let's quickly get down to the challenge first. So let's go back to the early 90s and maybe and then we'll move up to 2000 and now. The earlier challenges were quite different in terms of when you were doing security research or pen testing of something. It was typically around exploiting a server within the infrastructure. You have web server, FTP server, whatever. That was at the top in the 90s. A lot of researchers were focusing on finding vulnerabilities and creating exploits for these server applications. And then came 2000, where attackers as well as researchers thought, wait a minute, what if we look at vulnerabilities at the client side, like browsers or client applications like readers and Microsoft applications. And that's when they started focusing on how do you go about exploiting the client side. And turns out, for the bad guys, it was more profitable because you could directly attack the target's machine and then exploit it and extract whatever data you need, or stay there for long, depends on what you want to do. And then there was a time when these smart devices or smartphones started to come up, and then attackers and researchers started focusing on these OS as well as these devices. And during that time as well, there was a lot of IoT and automation happening, and the cycle keeps on repeating. That's when researchers figured, wait a minute, now people have these devices, why don't we look at vulnerabilities on these devices? From a research perspective, it is an interesting and new area, but when you look at professional pen testing, it becomes a challenge, because now if you have to pen test, it's no longer just traditional IT infrastructure. And I'm not even going into the ICS or OT side, because that was considered like a different beast altogether. If you are now pen testing traditional infrastructure, you are bound to experience or find out these IoT devices within the network. And turns out that from an exploitation perspective, you would probably find more vulnerabilities in these devices. So why not go and exploit them directly? But the problem is these devices, they are huge in number, and when it comes to security research on specific IoT products or devices, that's a different story altogether. And one of the challenges or the challenges with IoT penetration testing or IoT security research is that uh, it's not a single tech or single entity that you learn and then you start exploiting. First of all, the attack surface is huge. Given any IoT product, intermediate to complex product, the attack surface is huge. You just do not have one tech that you will encounter. You have the mobile application that works along with the IoT product. You have the cloud where all the data and analytics happen. You have the hardware of the device. You have the sensors on the device. You have the RF interfaces on the device. You have new protocols, new IoT protocols as well as RF protocols, and then you have the firmware on the device. And if you sit down and start to pen test, this is a considerable effort as compared to just testing or assessing a web application, for example. The other challenge is the supply chain within the IoT product. So no single manufacturer can claim that we have created this product from grounds up. It's just not possible, because you take hardware components from somewhere else, you get your PCB designed from somewhere else, you create custom code on the firmware, you get cloud infrastructure from somewhere, you use security libraries or other functionality analytics or whatever libraries from third party. And from an assessment perspective, because you are the end vendor, if you have to look at security, you have to look at it from a holistic perspective and not from only the code that you have written. And you will typically have very less visibility into what vulnerabilities there might be in third-party software or hardware for that matter. So when you get down to security testing, there is no silver bullet for you to use. You can say, okay, IoT testing, let's use this and it'll help us to test the IoT. That's just not possible given the attack surface and the different components. And some of the challenges are that there are very limited enterprise grade platforms or products available that can help you with the new tech or the low level technology, for example hardware or radio protocols or IoT protocols. So basically you end up doing a lot of learning and lot of customization and lot of writing scripts for one specific product, which you may or may not use in the next research or next pen test. And from enterprise perspective, you obviously have threats like 0 days on connected devices which are accessible on the internet, malware that can infect, and I'm pretty sure everyone has heard about Mirai. And if you really look at Mirai, that was not something very complex in terms of what they were actually trying to do. It was more on knocking on the IoT devices and looking at standard ports and trying to access, brute force the passwords and get access to the device. And finally is the regulation and compliance. Now, from enterprise perspective as well as the manufacturer perspective, these are going to be a major challenge. As of now, a lot of organizations and standards bodies are coming up with IoT compliance standards as well as guidelines. For example, you have IoT Security Foundation, you have Internet of Secure Things, you have California IoT Security Law, you have ETSI 303645, and you have, I think, there's a standard in Singapore as well. Uh, there's an upcoming standard in my country as well, India, and ISO, of course, is coming up with IoT security and privacy standards. Now, these are bare bone IoT security guidelines and standards. We're not even touching domain specific standards. So when you get into domain like ICS, like medical, like automotive, every domain will have one or more of such standards. For example, there is 62443 for ICS, and there's an upcoming standard for automotive security, so on and so forth. So from a manufacturer perspective, the coming years are going to be a big pain, because you will have to comply with these standards if you want to sell in a specific market. And given the fact that these devices are just going to increase, I've just mentioned the statistics from our website, but I'm pretty sure that these are going to increase by the day, because and we are going to see IoT being deployed in critical operations as well going forward. And here is the interesting part about when you deploy IoT in for a critical operation. It's no more about doing those James Bond style exploits and getting access, staying there. That's one aspect. But think of an IoT device placed in a very doing a very critical operation. What you need to achieve your motive, you can just make it malfunction. And I think from a research perspective, exploitation might be a bit of a challenge or difficult for attackers or researchers to figure out, okay, ways how would you go about exploiting the firmware in some specific way, so that the device continues to work and you have access onto the device, rather than uh, comparing that with a new IoT protocol where you find a vulnerability and you can just DOS it, right? And think about devices kept in ICUs, think about devices kept in nuclear power plant, you name it. I mean, the devices are everywhere. And that's a very big challenge from a security perspective to IoT. Now, learning the hard way. 6-7 years ago, when we started research into IoT and offering IoT as a service, we were all geared up. It was something new that we were working on. Looking at hardware, looking at firmware, it was pretty exciting. And we thought that the targets will change, but the process will remain the same, right? Like, you will get access to something, you have to figure out information that can help you bypass certain controls or find exploits. So how difficult would it be? Throw any device on us and we're going to beat the shit out of it, because that's what we do day in and day out. Whether it is a web application, whether it is a thick client application, whether it's a mobile application. From a pen tester or a research perspective, your focus is towards finding bypass to either exploit a component or get access to a privileged part of the system. But as we started testing, this is what eventually happened, and we ended up procuring different hardware tools, looking at various open source as well as commercial tools. Obviously, some of the tools will remain the same, and some or most of the tools will change based on the interface of the IoT product. So what eventually happens is there are just too many interfaces to assess for even a single product, and then there are too many tools required for assessing each of the interface or the attack surface for that product. So what happens is you look at what are the hardware tools available that you can use, what are the open source tools available that you can use, what are are there any scripts or anything that is available, any commercial tool, economical commercial tool which you can use to test it. So basically you spend a lot of time on that. You find most of the times you will find some tools, but those will be probably hobbyist tools or somebody who encountered this thing and wrote some custom scripts and released it online. So you will then try and use that code. You'll find a lot of issues, want to customize it for yourself. So basically you'll spend a lot of time fixing issues in open source tools and customizing it to your requirement. And eventually at times what happens is you just say chuck it. Probably I'll have to create my own custom code to do a specific job. Reasons could be there's nothing available, or whatever is available is not cannot be customized to our requirements. So if you really look at it, we are spending more time on learning to use tools, learning the way how a tool works, writing custom code to fix these issues, or writing custom code to create your own customized code to do a specific job. And then when you move from that IoT product to some other IoT product, let's say you're doing a consumer electronic, and then you suddenly move to a healthcare device, most of the stuff that you created, the custom code, might not be very useful or feasible for this device. And then you have more protocols that you have to work on. So you start from step zero. You repeat the same process and then perform the actual analysis or assessment. So you see there's a lot of time that is being wasted, which can actually be utilized into analyzing as well as assessing the product, whether it is their code or interface or whatever. And ideally you shouldn't be bothered about, okay, what do I use to communicate with this, what do I do. And so this is the challenge that we were facing in our early days when when we were moving from one IoT product to another, like testing a medical device, then testing an automotive device, then testing a building management system device, to an ICS device, and so on and so forth. So then we went to the drawing board and we thought, okay, what is it that what are the problems that we are facing? One is there's a lot of manual effort involved in or tedious effort involved in assessment, which is not directly impacting, I would say, or related to the actual security analysis. If we can automate this, that will be really helpful. The next is the learning curve. Now, for every new protocol, every new interface, we have to go dig deep into it, then come up with custom scripts, then look at what other open source tools or commercial tools are available. Is there a way in which we can reduce that learning curve, in which, let's say, today we are doing BLE, tomorrow we are doing ZigBee. We should not be bothered much about what do we do with this, rather than just getting an understanding of ZigBee, and then we know what are the test cases that we want. And by the way, here is something that we can use uh, to achieve our objective, rather than creating it from grounds up. Uh, is there a way in which we can standardize test cases or misuse cases? Like there are certain specific things for specific protocols and interfaces that you can automate and standardize, and then based on those, on top of those, you can customize based on your requirements. For example, if there is UART communication for a custom console, can we standardize this and then have then basically based on the custom console and other things, we can probably just add minimal code to it so that it can perform a specific operation. And lastly, can we do everything from a single place? And that's a huge challenge. And one of the important things of doing this from a single place is that uh, if you're doing it professionally, it really gets messy when you're using different tools. You'll have to manage their output differently. Anyway, so is it possible to do everything from one place? So basically, when we looked at all of this, we were looking at what if we can create a Swiss Army knife for IoT security assessment or exploitation. So that got us thinking, and then I sat down and just tried to write something. And over time, I realized that this could be possible, at least from the most interesting interfaces or the attack surface. We could figure out, we can create something which can standardize and help us as well as the security community. Now for things like web in mobile, there are already a lot of good tools, so we really do not need to automate that. But for things where there is there is not much available, I think we can add some value there. So that's when we started to create the EXPLioT framework. This is an open source framework. You can find the source code on GitLab. There is documentation available on how do you use, as well as how do you customize the framework. The documentation is available on readthedocs.io. And as I mentioned, from the problems we faced, we were looking at really creating a baseline framework where we can keep adding new things, as well as the community can add things or customize it for whatever they specifically need, rather than creating things in silo which will not help anyone at the end. So let's look at the basic architecture of the framework, and it is pretty simple. It gives you, you can use it as a tool as well. It gives you a command line interface. It is available on you can download it using pip3. It's a Python 3 based framework. You can install it through pip3. It gives you a CLI. You just run the CLI, and then you can interact with the plugin, with the framework, and basically run the plugins to do specific stuff. So internally, there is there is a test class which the plugins inherit, and every plugin does something specific. Now, if you are familiar with Metasploit or other such frameworks, it is somewhat similar to them. Only thing is the scope of EXPLioT framework is only specific to IoT. So then you can write your plugins based on what interface you want to use, or what interface you are targeting, as well as what protocol you are looking at. And then we wrap everything so the CLI will call the specific plugin based on what the user wants to run, and we'll come to that. It's a very simple interface. What exactly is a plugin? Now, this is where, if you're interested in writing plugins, it is very simple and easy to add a plugin for a custom or a specific requirement, given that the interface or the protocol is implemented in the framework itself. So basically, the first is the definition of the plugin, which is plain English. You specify the name, summary, description, and the arguments for the plugin, which you can take directly from the user. As you can see, that's pretty simple. And that's the second part, the requirements, in which you just specify the arguments and what exactly do you want the plugin to use for its operation. And the third and the final part is the actual business logic or the misuse case that you are going to implement in the plugin, where you use the protocol library or the interface library and achieve your objective, whether you're exploiting or whether you are just scanning or doing whatever you want to do. And then based on the results, you can specify whether the plugin passed or plugin failed. There are two functions called pre and post. They are optional methods. Pre is basically called before the actual execute method, and post is called after the execute method. And that's just to give kind of a functionality for running it as a test suite. Typically in your enterprise, you would for enterprise or startups, you would want to have a tool which can help you with automating certain tests, so whether it is regression or smoke test, whatever it is, you can utilize this in within your SDLC as well, or DevSecOps as the new terminology it's called. So as far as the current plugins are concerned, we have some standard BLE plugins like Scanner, interact with the BLE device over GATT, fuzz the characteristic values. We have MQTT, publish, subscribe, authentication cracking. If it's AWS IoT, then we have publish and subscribe for AWS IoT. We have simple Modbus read write. We have simple can read write and fuzz can plugins for DICOM, which is a healthcare protocol. We have echo, find, and store plugins. For COPE, which is again an IoT protocol, we have get, post, put, and delete plugins. In discovery, we have MDNS discovery, we have UPnP discovery, BLE, Zigbee, you can, and as well as COPE, you can do automated discovery of services and devices. For Zigbee, we have sniff, replay, network scan. So Zigbee here is an example of functionality for a proprietary tool, although the proprietary tool is ours, but the idea here is that anybody should be able to write plugins for open source as well as proprietary tools. So let's say you have some other hardware tool which gives you a kind of an interface to communicate with it for doing certain specific things. You can write plugins for that within the framework and publish it so that we can add it to the framework as well. And if it helps the community, we'll definitely love to add it. Same is the case with the hardware debug port scanner. We are currently using it with, we have plugins for our debug port scanner, which is called Bus Auditor. And then there are plans for adding functionality for, JTagulator and other hardware tools. On serial, You can fuzz the serial communication if there is a custom console, for example. You can brute force the serial communication with the device. So basically UART communication. You can read write flash or EEPROM memory, and we just have a couple of exploits. To those are more as an example that it's not difficult to write exploits on the framework. So typically you can write an exploit for any IoT device, and if there is any functionality which you require which is not part of the framework yet, we would be more than happy to add it in the framework. Or if you already have knowledge about it, you are free to contribute to it so that it can help the community at large. So a very simple, that's the banner. They're pretty much just a few commands that are important. List is to list down all the available plugins. Run is to actually execute a specific plugin. So you say run plugin name and the options for the plugin, and exit and quit. So if you list, for example, you can see all these plugins that are available for use within the bare bone framework or the standard framework that you can install from through pip. And if you want to know how a plugin works, all you need to do is just run plugin name -h, and it'll give you the documentation and the parameters or the arguments that the plugin requires. So it's pretty much a standardized way in terms of how you're going to use it. If you don't want to use it in an interactive mode, you can always write custom scripts and automate these plugins directly, which becomes very helpful for, as I mentioned earlier, in the enterprise scenario or startup scenario, where you would really like to automate certain test cases when you are developing your product. So you can add your security test cases and then automate as and when the new build comes. You can run the all the test cases. All right, enough of talking. Let's get into some of the demos, and I'm sure you'll like it. All right, so in this demo, as you can see in the cam video, there are two devices. This is the target device, and this is bus auditor. I'll tell you what we are doing. So right now what we have done is we have connected bus auditors pins to an unknown pin out on the target board, and what we want to do is we want to scan for known JTAG ports on this device. So for that you can run bus auditor JTAG scan. Let's quickly check the help. This is how you can check help for all the plugins. And it says voltage, so we need to specify the voltage. The voltage of this particular target board is 3.3. The start pin, which is 0, and the end pin, which is 4. So I have connected the pins 0 to 4 of bus auditor to this target board. This can be in any order, doesn't matter. And then I'll go ahead and run the scan. It will go ahead and start scanning for these ports, and as you can see now, it goes ahead and tells me it found 2 JTAG devices and the exact pin number of each JTAG port. So for example, it says TCK is 2, which means that it is this particular pin number 2. TDO is 0, so it is one of these pins, and based on that you know which pin is what on the target board. So now you have found out the JTAG pins on this target board.
Now let's go ahead and as you can see, there is a smartwatch here in the cam video. What we are going to do is we are going to fuzz the characteristic on this watch, a specific characteristic. Now how you find out which characteristic? There are a set of steps that you need to do. So you need to identify the BLE address of the device. Then you need to enumerate on the characteristics that are available. Then you can sniff the communication between the mobile app and the watch to identify, when you trigger an action, which are the characteristic handles and values that are written to. So what we are going to do is we are going to fuzz a known handle, which is 0x00C, and we are going to take a known value which is written to this device, and to fuzz we just mark the specific byte in this value as XX. So here I'm going to fuzz the last 2 bytes of this particular hex value. So this will go ahead and start fuzzing for 255 iterations, and as you can see now, different behavior on the device. So for example, in this case, you can see that the camera operation has started. Now based on the device, you may find different behavior in different devices. So we have found devices rebooting, devices going into firmware update mode, and so on and so forth. So this is a very handy way to find Bluetooth specific vulnerabilities, for example. Okay, now let's talk about some software. So you might have heard of the protocol called MQTT, which is quite famous IoT protocol, and a lot of IoT ecosystem and products use MQTT. The way you can interact with MQTT is through publish or subscribe on a specific topic. So I will show you a very simple example. There are other plugins available as well. I'll just show you subscribe plugin. So what this plugin does is, in this plugin you can subscribe to a topic on an MQTT server, but what we are going to do is we are going to subscribe to a special internal topic called $sys, which is basically used for system generated information, ideally should not be allowed to be subscribed by normal IoT devices. So now I'm subscribing to this on test.mosquito.org. It will go ahead and communicate over MQTT, and it's going to give me all the information about the broker. And the interesting fact is that one of the topics, $sys broker/version, tells you the software name as well as the version of the software being used on the MQTT server. So like this, there are so many different plugins that you can use. For example, for COPE, for DICOM, for MQTT. MQTT also has an authentication cracker. Let's say if the MQTT server uses authentication, you can try and crack the authentication or brute force the authentication as well.
I hope you liked the demos. So this is just the beginning, and we have a long journey. We have a lot of things that we have to implement in the framework, and feel free to reach out to me if you want to contribute in any way, or if you think there is something that we can implement within the framework. A bit of a shameless marketing plug here. We are creating a platform for IoT vulnerability management, and we are more than happy to share it with the community. So if you see on the top right side, there's a QR code. If you would like to get access to the limited community version, please do fill out the form, and we would be happy to give you free access to the platform. Finally, thank you so much for giving me this opportunity to come and speak at Ekoparty. I would really love to come there physically one day. Hopefully that is soon. Till then, keep your hands clean, wear masks wherever possible, and stay safe. And if you want to reach out to me, that's my email address, and we can have question answers now. Thank you so much.